Welcome to class tonight. I do hope that you are having a wonderful, wonderful night. Now, tonight, we should be having a really easy, and actually it should be a pretty quick lesson. We have actually been getting setting the stage for this lesson all chapter, actually. You've learned about variables, and then even learned about how to write equations. That was last week. The last step in this whole process is solving these equations. So let's go ahead and jump right in. Now the picture I want you to see, and actually the picture I put on on the screen in front of you, is the picture of a scale. Now we use a scale to tell us which side is heavier. Okay, so maybe you guys, when you were studying weights or measurements, you used a scale to tell out which one. So this is what we call a scale. So basically the idea is you put something on one side and it tells you which is heavier. You should think of an equals sign. Okay, you see the equal sign right here? That equal sign, you should think of it as similar, in some ways, to a scale, actually. Now, for example, if you were to put 4 pounds on one side of a scale, you would need to even it out. So to get the scale straight again, you would need to put 4 pounds on the other side. Now, equal signs are similar to scales because both sides of the equal sign need to be balanced. For example, right here I have on the board 8 plus 4 is 12. 3 times 4 is also 12. So right here, this and this are the same. They are balanced. Okay? If they are balanced, then we can use an equal sign and we're good. That's a good thing. Now, if we were to change this up, let me change this up a little bit. Erase all that. There we go. Remove this one. Put that one. Oh, I threw it somewhere. And put that one in the trash. So now, what if I were to do this? 3 plus 3, and then 5. The question is 3 plus 3 equal to 5? Well, no, it's not, because 3 plus 3 is 6. So this is what we call a non-equal or unequal. Remember, this is the symbol for unequal, a slash with the equal sign. This is what we call an unequal equation because it is not equal at all. Let's do some other ones because there's actually a nice term we use for this. So let me pull one out. Ooh, 45, and then 4 plus 5. So the question is, does 45 equal 4 plus 5? Well, the answer is no. It is not equal. It is unequal. So now we would call this, whenever you see this sign, we would call this a false equation. Okay, that's what that's called. When this does not equal this, we call that a false equation. All right, so let's go ahead and try some more. There we go. Put this in the trash. Put that in the trash. Pull out some more. All right, actually put this one over here. 63 and 7 times 9 and 63. Is it a true equation or a false equation? Well, 7 times 9 actually is 63, so we'd call that a true equation. Okay, so this is equal to, say, because the equals sign tells us that both sides are equal. They are the same. Put these in the trash. Last one. 18 and 6 plus 3. 6 plus 3 is 9, and this is 18. Well, 18 is not equal to 9, so we would call this one a false equation. That's what that is, a false equation. Let's go put that in the trash now. Now, I want you to think of one more thing. I want you to think of these equations and these equal signs as I need to figure out sometimes what makes it equal. So for example, if I was going to put x plus 3, so x is my variable, x plus 3 on one side of the equal sign, and then 6 on the other side of the equal sign, the question is this: how do I make these two sides equal? Well, all you have to do is say, oh, if x were 3, so if x were equal to 3, so 3 plus 3, that equals 6, and then they will both be equal. So if x equals 3, it'd be 6. So you do it like this, and so that would be the answer right there. So I figured out, I said, all right, there's an inequality. Something's wrong here. I have to make them equal. And so I said, all right, if x is 3, then this is equal. Let's do 1 or 2 more. Now, actually, I have some other ones on the other page, but I like this symbol right here on purpose. Let's do 1 more. Let's do q minus 3 on one side. And let's do 3 on the other side. Okay, so q minus 3 on one side, and then 3 on the other side. So what could we do to make that equal? Well, let's see. If this is, it has to be bigger, so q has to actually be bigger than that. So it's 4. 4 minus 3 would only be 2, or will only be 1. 5, if q were 5, it would only be 2. Ooh, if q were 6, q equals 6, then 6 minus 3 equals 3. And it's a true equation. So you see, I use my mental facilities to solve this equation. Now, the book has some other ones. These are some other examples that I want to kind of work through as quickly as possible. So let's think about this. N plus 14 equals 25. So I want to get both sides equal. I want to get both sides equal. Let's think. 14, so something plus 14 is 25. So let's think. 10. 10 plus 14 is 24. Ooh, if n were equal to 11, 11 plus 14 would equal 25. So you see, I use my mental brain, I use my brain and solve this. All right, let's do this one over here. 17 minus x equals 8. So I want this side and this side equal. So what can I do? Let's just start with our numbers. Let's have 5. 17 minus 5 is, that's 12. So I need a bigger number. So 17 minus 6. No, 17 minus, let's try 8. 17 minus 8. Ooh, we're really close. That's 9. How about 17 minus 9? Ooh, there we go. That does equal 8. So x is equal to 9. Finally, this last one, w, remember this is the sign for divide by. W divided by 4 equals 20. So what divided by 4 equals 20? Ooh, well, that's got to be a really big number, right? Because it's division. So let's do 200. 200 divided by 4 is, that's, well, still a big number. So how about, well, let's try some numbers. Let's go 100. 100 divided by 4 is only going to be, 25. Ooh, that's pretty close. Let's get even smaller. How about 90? Oh, that's not going to be even, is it? So that's not going to work. Ooh, how about 80? There we go. 20 times 4 is 80. So W is equal to 80. When I put 80 in for W, this becomes a true statement, and that's the goal. So we solved this just using mental math. I just guessed. I tried some things, and it worked out. The last step the book wants you to take is estimating solutions. Now remember last chapter we estimated decimals, and so when you look at this, you're going, wow, Mr. Hurst, those are big, scary numbers, and they are. But remember, with estimating, I'm not looking for the exact answer, I'm looking for a pretty close answer. So let's see. What is a number pretty close to that? We'll start with this one right here. What's a number pretty close to this? That's easy. Well, 3.85 or 3 84 hundredths is close to 4, right? So how can we say n minus 4 equals, that looks a lot like 12, right? 12 and 33 hundredths, that's similar to 12. I can solve this one now. N minus 4 equals 12. So let's think. What minus 4 equals 12? Let's throw some numbers out. How about 20? 20 minus 4, no, that's 16, but I'm close. How about 15? 15 minus 4 is, 11. I'm close, so that's not right. How about 16 minus 4 equals, and there we go. So n equals 16. Now remember, this is an estimate, so I actually should, let me erase this and put it right. N is about 16. Remember this symbol right there? This symbol means about. Okay? All right, let's keep going on. Well, 12 is a nice, easy number. Let's keep that there. But 105, that's not a nice, easy number. So I'm thinking, what times 12, something times 12 equals something close to 105. Well, let's think. 12 times 5 is 60. That's too small. 12 times 7 is 84. I'm getting closer. How about 12 times 9? 12 times 9, that's going to be 100 and, oh, need to write that correctly, right? 12 times 9 equals 108. That's really close to 105. So let's say this. So n is pretty close to 9. N is pretty close to 9. It's not exactly, but it's pretty close to 9. All right, last one. Back to big, scary numbers. 6 and 1400ths. How about we just say 6? That's pretty close, right? So y minus 6 equals 23 and 8/800ths. Let's just say 23. Make it easy, right? It's pretty close. All right, so now I can solve it. That's pretty easy. So something minus 6 equals 23. So let's see. Well, how about, let's throw some numbers out. So 30. 30 minus 6 is 24. So why don't we say this? 29 minus 6 equals 32. Oh, 23, sorry. 29 minus 6 equals 23. And that works. So y is pretty close to 29. So I use those simply by getting pretty close. Not finding exact, but just getting pretty close. All right, well, ladies and gentlemen, that is it. Tonight, you simply need to remember that the equal sign that you see is very similar, and I'll go back, very similar to a scale. Both sides of the equal sign need to be the same. You must balance the scale. Focus on that. Your homework tonight is going to be page 86, 4 through 18 even. Once again, page 86, 4 through 18 even. Have a wonderful night, and we'll see you all tomorrow.